Hello, everyone. Thanks for joining the second Tip Talk of today. So, title is Unexpected Gifts, the impact of AV research on automotive safety. As was stated, I'm Aaron Jefferson. I'm VP of Product at Luminar. We are a LiDAR technology and supporting software company delivering into the automotive for autonomy and safety. And today we're here to talk to you about safety, in particular, the NHTSA rule and why it's important and how LiDAR can help with that. All right, so in terms of, what are the challenges that the OEMs face in meeting this new rule? There's a lot of conversation about that right now, and it really ties down to, the ability to really detect objects and induce actuation on that confidently and positively versus false detection. And I've spent my career a lot of years in safety, camera, radar. I'm very proud of the work I've done with a lot of my colleagues and companies. But the systems today are inherently have some challenges in terms of being able to meet the new rule, to be able to detect objects and pedestrians confidently while not inducing inadvertent braking. And you heard a lot of discussion today around consumer education. What do consumers understand about AEB? What do they know? What do they not know? And that is an issue. But one of the major topics is if you've ever been in an inadvertent AEB event, and I have, it is extremely uncomfortable and scary, and that kills the confidence of these systems. Also, OEMs know that there's one thing to meet a rule, there is another thing to actually have a false AEB event every 1,000 miles or so and have extreme customer dissatisfaction. So the challenge here is, how do I balance that? How do I make sure I create a technology that can detect everything I wanted to detect, stop reliably, confidently detect these objects, not have false detections, such that I have this phantom braking and that I continue to build the confidence that Rose Kind and others talked about in terms of really enabling the capability, bringing the consumer base step by step along through this path. And LiDAR can help with that. So camera today, again, I mentioned my history there. 2D sensor does a really, really good job at providing context of the scene. What's going on, just like our eyes do. Where's the road boundary? Who's in front of you? How are cars moving and things in that nature. But it's extremely difficult to understand exactly every aspect of how fast the vehicle is moving. How much time do you really have to turn across the path of an oncoming vehicle? And so it has somewhat inherent shortcomings of exactly what it can detect. Radar is an excellent sensor at detecting moving objects. However, it has no idea what it's detecting. It doesn't know if it's a bicycle, it doesn't know if it's a car, it doesn't know if it's a motorcycle, it doesn't know if it's whatever's reflective that it can get returns from. And so those two work in concert together, both with some inherent shortcomings to try to get some confidence and say, yes, we know what this is, we want to stop for this. What LiDAR does deliver is a 3D comprehensive point-by-point set of information for the vehicle to understand and say, okay, not only do I know the context of this scene, but I also know the size of the object, I know which way it's going, I know the velocity, and I know the 3D point measurements in space of where it is in relation to the road, in relation to the road edge. So all that information together, that rich data information, which is also low in terms of compute load, is very valuable and works very well with the other sensing technologies. And so, when we really think about, okay, well, what's next? How do we build that confidence of detection? The answer is we have sensing technologies that can help support that. As you enter the event today, there is a EX90 from Volvo there with LiDAR, a production vehicle with LiDAR on the vehicle, in the crown of the vehicle. So it is a first step of really implementing long-range, high-capability LiDAR, not only to deliver autonomy, but again, more focused here today on delivering better safety. Now, if you look at the NHTSA rule, the graph off to the right, it's really extending and saying, it's a big step. It's really our path to say, hey, we want to try to eliminate accidents. We want to save lives. We want to be very direct about what we're doing. And so it's expanding the speed. It's saying no contact, which is a big deal. And so with that, there's a ton of safety benefits, but was mentioned by Adam Raviv earlier, it's a start. It is the start now to then how do you expand beyond that? And we work with a reinsurer, Swiss Re, who has all of this global data collected around all these different accidents So what you see here in green is essentially all the other accidents that happen. I wouldn't even call them corner cases. Low light conditions, crossing path scenarios, intersection scenarios, in which there are tons of daily occurrences that we go through every day that still aren't covered by any mandate or any kind of NCAP incentive or anything like that. So what LiDAR does also give you is a roadmap for greater improvement in safety, not just what it can meet today or an immediate need, but it provides much more capability. And that's where the AV space comes in. We've been funded largely, we're public now, but we've been funded largely by autonomous vehicles and innovation and technology, tons and tons, actually, billions of dollars being poured into an industry that not only supported LiDAR, but also supported artificial intelligence, machine learning, compute. And so it's important that, again, we have a technology that is ready, that is production, starting production this year, and can be deployed to help support not only today's safety need, but also the roadmap for future safety. Let's see. Okay. So again, I don't want to downplay the difficulty of what NHTSA is trying to, force into the market in terms of the no contact rule and the higher speed. It's hard. I'm an engineer. I designed, before I got into the executive status, I designed a lot of these things. And there's tons of resources and tons of engineering required to actually bring it to fruition. So I don't want to downplay that. But there's technology available today and ready for the market. I think part of what we heard today also was talk about collaboration. We have all these individual companies that are coming up with these ideas, and hardly do we ever cross boundaries and really talk about how we work together for the greater good of safety, to where I think if you really think about what this new rule is trying to do, we could actually have the safest roads in the world here in the US and expand that globally. But it does take collaboration, partnership from OEM to tier one to technology company to investment company to government. And with that, I think we can excel things and get things ready. Our one thing that we try to do, and I think is important, part of that collaboration is Luminar has developed a software, what we call a SDK or a software development kit, to try to enable our OEMs to be able to develop software faster. So instead of just saying, hey, we have this solution, we're trying to make sure OEMs are spending less money on engineering and that they have the right tools to utilize LiDAR for the best benefit. So, and that's not just us, that's widespread through the industry. So again, how do we help enable our OEM partners to really carry this forward and not necessarily focus on why the rule is here, but how do we address the issue and how do we address the problem and solve for that problem? So again, I thank actually all of this because my career has been fueled on safety. It's the reason I'm here today. And the reason I'm at Luminar is because when I first joined, Austin Russell said, hey, yes, autonomy is important, but let's talk about safety. My whole interview was about safety and how LiDAR can come in and basically be a step change in function and capability for safety. And so when I think about that, I say, hey, kudos to the new rule. Now, how do we go about doing it? It's going to be difficult. It's going to cost a lot of money. It's going to take a lot of engineers. It's not easy. It's hard as hell. But anything that's worth it rarely is. Thank you.